Hello, everyone, and welcome to a pre-recording in anticipation of our upcoming Beneficial AGI Conference and Summit that will take place in Panama from February 27th to March 1st. In anticipation of the event, we wanted to introduce you to some of our outstanding speakers who will tell you about their background as well as their contributions that they will bring to our conference. So, in this regard, I have with me today Professor Erik Schoppen, who is a true Renaissance man whose knowledge and interests span cognitive neuroscience, social sciences, computer science, while at heart, and actually, as he confided with me, he was born an artist and a designer. So I'd say that creativity is his main trait. As many of us share here as artificial intelligence folks who like Dr. Ben Goertzel, who is also a musician, I'm a poet, and so on and so forth. So welcome to the community, Erik, the community of AGI creators. Um, I'd like to say a few things about you before I start with some of my questions. After conducting neuroscientific behavioral research on trusting sustainability at the University of Groningen, Erik dedicated all his energy and his unique background and experience to the cause of increasing trust in sustainability. Erik, your passion and expertise lying in investigating the intricate dynamics of social trust from an interdisciplinary perspective, spanning neuroscience, trust, and AI. And in this regard, I will read for our listeners your statement of contribution to our BGI summit. It's very brief. So you said that we urgently need to discuss trust interdependency between biological and artificial intelligences. Biological life forms base their trust on available information to give meaning to reality. And so does AGI. A better understanding of how these systems can work together will enhance our ability to develop more empathic and objective learning and reasoning AGI systems, contributing to a more sustainable and safer world. And taking on from here, Erik, a major concern that you are raising in your work is the possibility that, on the evolutionary scale, the paths of biological beings and that of AGIs may start to diverge if we lose the connection between us and our own creations. Speaking of creators, can you please give us your thoughts in this regard about the danger for this divergence and how can we actually well, eventually avoid it or resolve it?
Well, thank you so much for the question, and also thanks for having me on this pre-episode. First, let me explain something. I'm not a professor in the sense that I have a PhD. I'm a lecturer, and of course I educate on the university, but I'm not attached to a university doing research. So I'm an independent researcher. But in the past, I did research on the University of Groningen. So, because that's clear, otherwise we get confusion. But yeah, that has to do that I'm a multidimensional artist, so you can speak. So I think the connection between science, design, computer science, this is all interesting, and this is how we build and reframe our society. So, but back to the question about the divergence. At the moment, we are at the brink. So, if you look at human evolution and the evolution of a human brain, it was always revolving around the human. Understand how our cognition and emotions and behaviors worked. Of course, also animal behavior. And now, of course, we are developing in a very high speed technology. It's actually divide our systems with other systems. These are, you can call this artificial intelligence or generative or name it what you want, but these are complex systems that can make autonomous decisions on their own, which will happen very soon. And this creates a, a void between how we reason, how we think, how we perceive the world with our brain, and I will explain some later on, and how these machines or these systems perceive the world and the way they make decisions. And in one way, it's an analogy. So I like to talk about the brain as an analogy for artificial intelligence. But there is some point, and you can call this a singularity or whatever you name you want to call it. There will be a difference in computing the reality, which is not understandable for us anymore. So that's the void that I'm afraid of.
And now that we spelled out the void, can you also address a bit how can we eventually bridge this chasm or avoid falling into it?
Yeah, well, that's an interesting question because we have to bridge the gap, and that means that we have to develop not only very improved computer networks, which will eventually anyway happen because this is how science works. This is how we work as we develop technology. We were looking for improvements. So these systems will become more autonomous, more fast, and they will make probably decisions which are going beyond our scope, our understanding of how our brain works. For example, now, if you go back in history, for example, if you go back 100 years ago, then we tried to understand animal behavior. It was the time of behaviorism. And actually, it was the black box theory. That means that we could only observe animal behavior and try to discover patterns and make predictions. Okay, this animal, this rat, or this mouse, or dove, whatever, does these things repeatedly, so we can predict it will do it in the future in the same way. Well, you can make an analogy at this moment that with machine learning, it's like the same black box theory. I mean, we see outputs of these computer systems, and actually we know a little bit about, like if you use TensorFlow or whatever, we know a little bit about the nodes, and we can predict a little bit what the outcome is. But this is just very rudimentary, these systems. So, and especially when you combine different AI systems, so not only machine learning, which is one-dimensional. So if you want to discover cancer cells, then machine learning is a great solution. But if you talk about a more broader generative AI solution, then you're going to talk about neurosymbolic AI, using mental models. This is exactly how our brain works anyway. Then this black box is becoming a huge enigma because it's beyond our scope. So yeah, that brings us some challenges, and we have to create some connections between the biological world and the artificial world. So this is why I made this statement, and I think this is one of the prime reasons that we meet, because we need this discussion. Otherwise, we are developing very complex systems that have a complete existence of their own, and we are just bystanders as humans.
I agree, and totally aligned with your view that the brain actually works in a neurosymbolic reasoning is the best way to model how it works, because this is exactly the approach which we have embraced in our research team at SingularityNET,
Oh, really?
as you
Okay.
may well know. Yes, yes. Oh, you didn't know. That's amazing. Yes, yes, exactly. And that's why we are so thrilled to have you with us and that you accepted our invitation. And we cannot wait to meet you and discuss maybe more research collaborations with you when we meet in person in Panama. Of course, this is also, yes, a big issue is explainability. Yes, how do we open this black box and see what's inside? And I think neural symbolic has also something to contribute there. But I would like, if you can, and of course these are, as you say, open discussions, and that's why we have the conference in the first place. But if you can underline some of the dangers, or let's say major or whatever dangers you can foresee that can ensue if we carelessly design AGIs who can know us better than we know ourselves. I know this is one part of research which concerns you, and that you've been thinking a bit about this.
Yeah, well, thank you for this question also. But yeah, I mean, we use different neural networks. So the most rudimentary neural network that we use is our neural network. And now we are we had some recent findings, which is very interesting. Is about memory storage. So the orthodox, old-fashioned way you can call it is how we store memories in our brain. And so when we have a neural network with some nodes, then probably somewhere a memory is stored. Actually, we don't know exactly how this works. I mean, we know that replacing with neural receptors, it's changing the modality within those neural networks. But this is something that's exactly happening with spiral neural networks in AI systems. So there's an analogy. And what you see is that these AI systems are copying our way of reasoning. So they mimic our neural pathways, so to speak. And this is a little bit philosophical because I actually don't know. But this is how I imagine it, how this black box theory works. But these AI systems are watching us, observing our behavior, our patterns online. Everything that is digital traces, leaving digital traces, is of course scooped, is putting in the system. So and of course we have automated routines. We are very predictable as humans because we do every day the same things. I mean, we brush every morning our teeth, blah blah blah. So these AI systems on a neural level are very easy to create a future for us where they can walk before us to make decisions. And this is interesting because if you look then at social networks, it's like a copy of the neural network. Then we put all our predictions and the way we think and our wishes and our beliefs and our attitudes and our behaviors, putting in autonomous agents. So within 5 or 10 years, everyone has you can call them an avatar or a second whatever, second twin, or you name it. And these agents will create autonomous decisions for you to make your life easier or more efficient. And this was the example that I used in our pre-discussion. So when I have a partner and my partner is also using their autonomous agent, then this is where we make the shift from biological trust, because I have a partner, and if I trust my partner, it's on a biological level. I mean, it's the neurosignaling in our brain. I have peptides, I have like endorphins and dopamines, and this gives me also a feeling of arousal or a trust feeling, like oxytocin or serotonin. That doesn't matter, but these are all kinds of chemicals that create these trust systems within our brain. Now, these agents actually, they don't have really this kind of chemicals because it's a digital system. So they mimic these trust systems. And actually, we cannot predict if these systems are the same trust systems as we have. So this is the first divide that we have. You have biological trust is based on a neurochemical system. Very important for our survival. Because it saves your life. This is why I mean, trust is very old. We have to go back 450 billion years ago, in the very early start of the evolution, where the first nerve cells were created. We actually use the same neurochemicals now in our brain. So it's a very old system. And of course, it's very successful because it brought us here in evolution. And now we are on the brink of creating these kinds of systems which are completely digital, and they will create their own trust systems, which I don't know. I mean, I don't have a marble where I can. It would be nice, right? Yeah. So
Nobody
that's
knows.
yeah. So that is an interesting area right now, because the coming 10, 15, 20 years, I don't know, decades. These systems will create autonomous decision making, trust decision making, which I cannot predict. And now the strange thing is, when we have autonomous agents going in our digital worldwide web. I like those old-fashioned names because, but this is actually what happened. They're gonna communicate based on their trust systems with each other. So I have an autonomous AI system or agent. My wife and my friends and my families, they or other people that I met online have their agents, and they will communicate with each other, and they create trust between those agents, which are not my trust systems, and they will make decisions that probably will not be my decisions. And now is the question: is this autonomous agent still have a connection with me making the decisions between other agents, or is it too fast, too complex, too highly educated, whatever, beyond my comprehension? And so that's just one thing. And then, of course, you have the digital networks. And these are way too complex already for the human brain. So this is why we try to bring it back in a scope that we can understand. But this is, I think, the challenge for the coming decades, to create an interface or something that we still can communicate with all these layers of networks.
Yes, no, this is fascinating and indeed an ongoing area of research. But, I have a different view here. I'm thinking, because as you mentioned, with our biological trust comes also, some limitations, like our decisions are subjective. Maybe I trust someone who is not trustworthy because I like their eyes, or who knows for what subjective reasons. I can make some biased decisions, and the AIs have the ability to make more objective decisions. And as such, the question is, I mean, there are many questions I think from here. So the number one, maybe they can make better decisions than us. I mean, I won't exclude that possibility, and I want to know your view on that. And second is, how do we know if we can trust their decisions? Maybe they are better than ours, but is there a way to know if we can trust the AIs? And then further, but of course, we will not tackle this here. After the singularity is there, we can tackle that, and maybe the AIs will answer. Can the AIs trust each other? So, please, whatever of these questions you want to address.
Well, the first one is it depends on the definition of what is better. A decision for an AI system, which can be beneficial for the AI system, is not primarily beneficial for us as humans. Even if you code or program the AI system in a way that it should, like the three laws of isomorphism, all these kind of things. But this is not how these systems will work within the future. I mean, they will be irrational. They will try to be empathic. And if you are irrational and empathic, you make very weird decisions. It's like finding your partner when you're drunk in the bar, and 20 years later you're married and you have 3 children, I mean, this is how it runs in life. And we expect from these systems that they are very rational and calculate every possible benefit, which actually is for the system a benefit, but not for us as humans. And this is about trust. I mean, trust is not only the leap of faith or being vulnerable towards someone else or something else, an agent. It has also to do with predicting the future. So when we are depending on systems that can make better decisions, actually what we say, okay, we are totally depending our future and our future decisions on these systems. And I think you get a boring life anyway. I mean, that's not what you want. So, I mean, you need some advice and some help from these systems. But actually, and this is about agency. We didn't talk about this, but agency is very important, and the locus of control. I mean, do you have enough agency in your life? And this is about trust dependency or interdependency, which this is one of the fears I have, is that we are so totally dependent on these systems that they force us in a way that we lose our freedom of thinking, we lose our freedom of movement. So, for example, I give you just an example. When a government says, okay, this is the best AI system at the moment, and it's autonomous and it is beneficial. right? For the human race or whatever, for the planet, for all life on this planet. It's great. Well, but it can be to save this planet in this life, that AI will transform itself within 2 years in a very repressive system, which takes away all the freedom of humans to save this planet. So therefore, we need this discussion. It's not like A, B is C, and this is the answer, and this will solve all our problems. Because some problems we cannot solve right away. Because if you have an AI system that has not really directly an influence on our behavior, for example, consumer behavior. I mean, if an AI system says, okay, to save the world, we have to stop flying. So what the AI system in the end will do, it will hack all the software related to flying. And then we're stuck. Well, that's not what you want, right? So this makes this kind of discussion so complex.
Definitely. And of course, this is the topic which you will lead at our conference. You will be moderating a panel discussion on early stage AGI technologies in education, medicine, and science. From your perspective, yes, which is your expertise in cognitive neuroscience, trust, and AI, and the intersection of that. So hopefully we will find some answers to these very different questions. Just before I ask you the next question is, just a comment. I think we already lost our freedom in today's systems, like in the social networks, as you mentioned before. I mean, how they are designed, these centralized platforms, and their models steering the worst in us, and hatred and dividing us. And that's why we're hoping that actually we can design better intelligences that can help us to come together and co-create maybe a better future, as you say, a more sustainable future. So this is actually our hope with the conference. But I wanted to ask you, what is your hope with the panel? What do you envision? Let's say, what do you think, or what are you hoping to shed more light on by brainstorming with the esteemed co-panelists there?
Well, what you see in science is that every research group is like the pintle of the needle, the top of the needle, and it's very specified on what they research on. And it's like silos, and everyone is researching, and it's very great research on the silo. But I think for this discussion, we need a broader discussion. So we have to make cross connections, but which may not seem logical at the moment. But when we have discussions, maybe this can be of interest. So that's what I hope that we met and that we make unlogical connections to steer discussions, which brings us some farther. Instead of having a discussion of what's the best neural model at the moment.
No, definitely, and I'm sure you will bring along some very exciting questions and topics for discussions at the event, which we don't want to disclose already because because we want to keep our audiences interested in the event itself. So, if you have any parting thoughts, maybe if you wanted to add to your brief statement, which I read in the beginning, or if you wanted to say something or answer a question which maybe I missed to ask right now.
Well, one of my hopes is we know a lot of the human brain. I mean, as for my background, I think that the perception system, how we perceive the world, I mean, not a lot of people know that you don't look with your visual cortex. That's what a lot of people. This is constructing reality. I mean, everything is an illusion, but we think with mental models. So when we perceive the world, and this is one of the challenges with AI, if you have a young child, maybe 3-4 years old, and you show this child a chair, then within milliseconds she can reconstruct this chair within her brain. And she's creating mental models. So this is the neurosymbolic, and then you have called the connection with machine learning. You can make this combination. But the weird thing is with the human brain, the next time this child sees another chair, it immediately recreates this mental model and it adapts fluidly. And this is something that AI still have to learn. But the problem at the moment is that a lot of people have different mental models. This is why we have war. This is why we have discussions. This is why we have different religions, all kinds of different mental models. And I hope, this is my personal hope, my personal belief, is that AI in some way can be beneficial to get agreement on the different mental models that people have in their brains and what they pass on to the next generation, so that we have a common ground, which I think is necessary to create a better and a safer world.
Yes, and definitely such mental models are very useful. Also, like mental models of trust, mental
Oh yeah,
models of chairs. It's
yeah. No,
one.
but it just was just an example to make it easy to comprehend. But yeah.
Definitely, definitely. And we cannot wait to have you with us. And I look forward to the panel, which you will be moderating, and as well to interact at a deeper level when we meet and dive more into possibilities for joint research. Thank you again for accepting our invitation. We look forward to meet you in Panama, as
All
well
right.
as
Thank
every
you.
one of you, all our listeners here. Join us either virtually or in person to listen more to what Erik and the co panelists, and of course, all our invitees have to share. Thank you.